Let's sketch the graph of the function f of x equal to minus 1/3 times x for x greater than or equal to -2, and we will use that graph to find the absolute and local maximum and minimum values of the function. So we have 2 minus 1/3 times x for x on the interval, or x in the interval from -2 to the right, that is up to plus infinity, close at -2. And we know this is a line that is determined completely by 2 points. So at x equal -2, the image is 2 minus 1/3 times -2, which is 2 plus 2/3, and that is 3. 3 times 2 is 6, plus 2 is 8/3. So the image at -2 is 8/3. And the other point we can use is for x equals 0, we get 2. So at 0, the image is 2 is here. And this is the image of -2, which we draw with fill a red circle. And then the function decreases all the time to the right without any bound. So with this behavior of the function's line, in fact, we can talk about a little bit before giving the solution to the problem, that this graph can also be obtained by some transformation to the identity function. In fact, we have the identity function like this. Then this function is multiplied by 1/3. That makes the function tilt to the right a little bit, because now the image of 1 is 1/3. So we have some kind of turn to the line is closer to the x-axis now. Then we have negative that is a reflection with respect to the x-axis, something like this. And then after that, we shift, we displace the graph up, or shift the graph up 2 units. So we get this, more or less. And that's it. That's what we found here, this line. So this is another way, but each time we have a graph which is a function, it's a linear function, we can draw it, whether the graph is a line, and we can draw it just determining 2 points. Okay, so now if we look carefully at the graph, we can see that we have an absolute maximum value equal to 8/3 attained at -2, which is this value here, is the highest point in the graph, and it's included in the graph because x equal -2 is included in the domain we are considering. So we can say here that f has an absolute maximum value 8/3, and that value occurs at x equal -2. There is no local maximum. That's because at any point on the graph, we have images that are greater and less than the image at the point. So There is no local maximum. And in the case of the absolute maximum, it is not local because we have no graph to the left, in fact. Okay, so with respect to the minimum, we had no absolute minimum because this graph is decreasing all the time to the right of the values of x. That is, there is no lower bound to the graph. So f has no absolute, but also local. There is no local minimum because for any point in the graph, there are points with greater images that are greater or smaller than the image of the point. So f has no absolute or local minimum. So the only thing that this graph has is an absolute maximum value of 8 thirds, which occurs at x equal -2. If we had considered this graph open on -2, that is, if this point here is not included in the graph, then the function would have no extrema at all. But in this case, it's included, so it's the absolute maximum value. That's it for this function.